Good morning, everyone, again. How are you doing today? Today, this room is warm, right? Warmer than yesterday. Not that cold. Yep. So, if you were absent yesterday or if you want to revisit the class from yesterday, you just have to go to our class Brightspace, and then on the left panel, you see class playlist. Click on the recording. And then you'll see our last class here. Yep. I'm going to put all of our recordings one after one. The newest one will be on the top, the oldest one will be at the bottom. So if you want to revisit the lecture, if you want to see the solution for your questions on the pre-lecture notes on Brightspace, you can simply go there because I don't have any solution for anything on Brightspace. And also, if you want, you can subscribe. If you want to subscribe, click on the page and then see the subscribe button. Just click that. But you don't have to click on the bell icon because I don't want you to get bored with all of my videos. I post a lot because I teach a lot. So don't worry about the bell icon. Just subscribe. That's fine. Okay. Any question before you start? Any comments? Concern? Complaint? Were you able to log into WebAssign? WebAssign, the homework platform. So if you have no idea how to go to WebAssign, you just have to go to homework icon, either on the top panel or on the left panel. And then they have section by section. You can click on those, or if you are doing it for the first time, definitely click on WebAssign instructions for to get WebAssign with lower price. That's the main idea here. Once you have your WebAssign information, the first week is free, and then you have to buy it for 4 more weeks, since our class is only 5 weeks. And then all the homework you can see here one by one. So you can click on view to view it. Sorry, this is my view. Never mind. As a student, you'll see something like this. So you'll see all the homework one by one. Chapter 1 homework due next week, Monday midnight. Okay, so let's see how much you can finish this week. But my plan is to finish everything in chapter week, and then do the homework little by little, so that you have to cram everything over for the weekend. How long does it take for the grade to upgrade to Brightspace? I have no idea. Sometimes it says 24 hours, but sometimes it's probably 12 hours or even less than that. But definitely within 24 hours, as far as I know. But I'm not sure exactly how long it takes. Okay, so homework every Monday midnight, the entire chapter, means so many sections. And then every Thursday, either you have quiz or exam. So this Thursday, you're going to have your quiz 1. Next Thursday, you're going to have your exam 1. Okay, so quiz 1, up to which material, I don't know. I'm going to tell you tomorrow. My plan was to give you at least 3 questions. Maybe I'll give you more than 3. And it will be like 15 to 20 minutes. So you can have the rest of the lectures, that's the time for our lectures. Any question? Great. So let me ask you, what's the standard form of a line? Ax plus by equals c. How do you find slope from that line? That's the slope formula if you're given 2 points. From the standard form, if you want to find the slope of the line, negative a over b. What's the x-intercept of the line? C over a. And y-intercept of the line? C over b. Great. Parallel lines. What type of slope parallel lines have? Same slope. And how about the perpendicular slope? Negative reciprocal. So you have to change the sign and flip the fraction. If you are given 1 point and the slope, how do you find the equation of the line? You need y-intercept, true. So you can find the y-intercept, or you can substitute x1, y1 and slope into the point slope format. Y minus y1 equals m times x minus x. Okay. And then we started function. We did evaluating some function. So when you are given a number, all you have to do is substitute the number and simplify algebraically using the order operation from this. And then if you're given a variable, your answer will not be a number. It will be based on the variable given to you to substitute for your x. And only for multiplication and division, we can distribute the power. But if you have addition and subtraction, for example, we have h minus 2 square, it cannot distribute the power. It's definitely not h squared 2 square. Instead, you have to FOIL them. So remember, that's very important. For addition or subtraction with the power, you have to multiply the same base power many times. Okay, now one homework question. It says we have f of x is a linear function, 24 minus 8x. Find all real values of x for which f of x is 0. F of x is 0, it means what is 0? Y. See, f of x is the y. So they're telling us, hey, this thing here is 0. So we have 0 equals 24 minus 8x. And then you just have to solve for x. So how do you solve for x? We can subtract 24, or you can simply add 8x to make it positive. Either way is fine. So we have 8x is 24. Now what times 8 is 24? 3. So x is 3. Another homework question. We have f of x is x squared, a parabola, and g of x is x, which is a line. Find all the x values where this parabola and line meet. So f of x equals g of x. How do you start? See, they're telling us f of x equals g of x. F of x is x cubed. Also, it's x cubed, not parabola, a cubic function. X cubed, and they are telling us our g of x is x. So we start by setting each function's right side equal to one another. And now there are two ways of thinking this question. Do it logically or do it algebraically. If you want to try logically, can you think of a number, if you multiply the same number 3 times, you end up getting the same thing? Definitely is one of them. 0 and -1. Yep. These are the 3 numbers. If you multiply themselves 3 times, you get the same thing back. So this is your logic, you're thinking logically. But you don't have to think logically. If you want to use algebra, you bring the smaller x on the left side, and you get x cubed minus x equals 0. And then what do you think we should do? Start with F, ends with T, sorry, ends with R. Six-letter word. Factor, good. What is the common factor here? X. So you factor out x, and then what is left? X squared minus 1. Can we factor x squared minus 1 more? What two factors we get? It's difference of perfect squares. Great. X plus 1, x minus 1. And then to solve for x, we take each factor, set them equal to 0 individually. And we have our x is 0, x is -1, and x is +1. And we are correct. We logically we found 3 answers. Algebraically we found also 3 answers. So logic was good. Any question? Okay, now intercepts again. X-intercept, Y-intercept. We know X-intercept is where the line crosses the x-axis or the graph, and Y-intercept is where the graph crosses the y-axis. So if you have, let's say, a function like this, these two are x-intercepts because they are crossing the x-axis. And this one here, it's crossing the y-axis. So this is y-intercept. For the format of the x-intercept, we have an x value and our y is 0. And for y-intercept, our y have a number, but our x is always 0. So for whatever intercept we have, the other variable must be 0. And now let's do some final exam question. Not here, later. Okay, graph. So depending on the graph, we may have 1, 2, 3, 4, 5, or 0 x and y intercept. It depends on the graph. So for example, the first parabola is above the x-axis, so it cannot have any x-intercept because we're not crossing the x-axis. But we have one y-intercept. And then usually, no, never mind. The next one is a cubic graph. In this cubic graph, we have 1, 2, 3 x-intercepts, and we are crossing the y-axis only once, so we have one y-intercept. And then we have some type of graph, I don't know. We have one x-intercept and 2 y-intercepts. And lastly, our circle did not touch either x-axis or the y-axis, so it doesn't have any intercepts. Now let's do some homework question again. The first graph. This is 15. And this is 4. And this is -4. These are -5, +5, and 5. And this is 4. Okay. Who would like to give me the x and y intercept for the first graph? Give me point format. 15, 0, 0, 4, and 0, -4. Perfect. Volunteer for the next question, next graph. Come on, these are baby questions. Go ahead. Zero, 5. Perfect. So 2 x-intercepts here, 5, -5, and 1 y-intercept, 5. Great. Now the last one. X-intercept and y-intercept. Mm-hmm. No y-intercept. So you write none. I feel like it's written. Is it five or three here? It's five. Then this is six. Yeah, it should be five because they gave us 10. So probably it's middle of five, middle of 10, five. But I can see from here. Anyway, and now we're going to do some algebraic x and y intercepts. So for graph, it's easy to see, just see and note them. But for equations, we don't see them. So we have to use the method to find x, make the y disappear. To find the y, make the x disappear. No, the first one. Let's find x-intercept. To find x-intercept, we are going to set y0 and then solve. To solve, we have to use so many methods depending on what we are given. If it's factorable, we always start with factor. If it's not factorable, then we have other methods to solve for x. So here, x-intercept. So what is our first step to find x-intercept? y0. So this y here will turn into 0. And we have 4x cubed minus 8x squared. And now how you're going to start finding the x-intercept. Factor, what can we factor? X squared. Anything else? We can also do 4 because we have 4 and 8. So definitely they both are divisible by 4. So once we factor out 4x squared, what is left? X minus 2. So good job. Step 1, set y0. Step 2, factor if possible. And what is our step 3? What do we do with these factors? How do you find x? Definitely you're going to find x. Set them equals to 0. So when you multiply several things and the result is 0, definitely one of the things you're multiplying has to be 0. For example, what is 2 times 3? 6. What is 2 times 3 times 4? 6 times 4, 24, right? What is 2 times 0? What is 2 times 0 times 4? You see? So if you multiply non-zero entries, non-zero numbers, non-zero anything, the answer will never be 0. In order for you to have the product to be 0, the things you are multiplying, one of them definitely has to be 0. So here we are multiplying 4x squared and x minus 2, and the result is 0. So definitely either 4x squared is 0 or x minus 2 is 0. We don't know which one. So we set each of them to be 0, and we figure out what makes each of them to be 0. And this is called zero factor identity or something property. So from here, we take the first factor, set it 0, because maybe this one's 0, or maybe our x minus 2 is 0. We know definitely one of them has to be 0. Which one we just don't know. So if 4x squared is 0, what is x? X is 0. 0 times anything is 0. So 4x squared, it doesn't matter what you have, the result has to be 0. And come on. Oh, I remember. Because my body is touching their machine. Yeah, it happened before in one of my classes long time ago. I forgot. So now see, I keep doing this and then keeps blinking out. Okay, so what minus 2 is 0? 2. So our x is 2. It works sometimes. True. Sometimes when I wait for the elevator, it takes so long. It happened a few times. It takes so long. And then I got angry and then I do this, I kick it. the door just opened right away. I was like, what's wrong with that? Okay, y-intercept. To find y-intercept, what do we do? All the x0. So we have y equals, this x is 0, this x is 0. So we have 0 minus 0. Come on. 0 minus 0. So our y-intercept is 0. Any question? So in your final exam, you are going to find x and y intercept, and that type of function they're going to give will be a little bit more complicated than this. So once we know about quadratic, then you'll see there will be one quadratic solving for x will be in the final exam. And you're going to use this factoring method, but in different version, different way. Okay, the next one, B. Y equals x squared minus 4. You can do it two ways. Actually, three ways. You can do it logically, or you can use factoring, or you can directly solve for x. If you think logically, what number square minus 4 will be 0? Or definitely 2, because we know 2 square is 4, so 4 minus 4 is 0. So definitely one of the answer is 2. We are sure. But is 2 the only number? If we set this 0 and we get x minus 4, add 4 to both sides. So basically this is asking for what is x square, when x square is 4. So 2 square is 4, we know. What else square is 4? Negative 2. So we have two x's. One is positive 2, one is negative 2. So we use logic and we use logic to solve directly. But also you can use factoring here. Can we factor x squared minus 4? What factors we get? Factoring. Factor. Or this is the difference of perfect squares. So we get x plus 2 and x minus 2 from this. So either x plus 2 is 0 or x minus 2 is 0. We don't know which one. For x squared parentheses x minus 2. Factor again for x squared. 4x squared doesn't have any partner. Okay. In order to factor out, you need a partner so that you can factor it out from all the partners. So 4x squared is just a single term, a monomial. If we had, let's say, 4x squared minus 2 or 4x squared minus 1, then you can do more. If you have 4x squared minus 1 here as a partner, you can use difference of x squared. And if you had 4x squared minus 2, you can factor out 2 as a more factor. But here it's just single monomial. So, yeah, but does it help? 3x times 2x is 4x squared. But does it matter? Mm-hmm. Okay, so we get x equals -2, x equals +2. So anytime you see difference of perfect squares, either use logic or use the two factors. Do you remember what do you call this type of two factors? When we have same two terms, just the middle sign is different. They have a special name. But these two factors, they have a special name. For example, if we have x plus y and x minus y, conjugates, good job. So anytime you have conjugates, anytime you have difference of perfect squares, means two perfect square and you're subtracting one from other one. You always supposed to get two conjugates. Means their bases, you add them, you subtract them. Okay, since we don't have space here, let me get a new page for our C. Oh, I didn't do y-intercept. So let's do y-intercept here. So we have y-intercept what? 0 square minus 4, which is -4. When we answer this on web sign, read carefully. Are they asking for just number or the point format? If they're asking for point format, but just give them number, you're not going to get points for that. I will tell you point format or not. C. What's the x-intercept for C? How do you start? 0. So 0 equals 4x minus 3. So we want to get rid of our radical. So square, the square root, square cancel out. What is 0 square? 0. And what do we get on the right side? 4x minus 3. Add 3 and 3. So we have 3 equals 4x. Divide by 4. And our x is 3/4. How about the y-intercept? Y equals 4 times 0 minus 3. So what do you get? -3. And do you know what is square root of -3? X and y intercept, they have to be real because they're crossing the axis really. No real solution. So in other words, no y-intercept. So it's a graph, it's crossing the x-axis, but it's never crossing the y-axis. Any questions so far? Nope. Okay. The next type of question is called rational function. Rational means you have a denominator. And for rational function to find the x-intercept, we actually do not set the y0 directly. Why not? Because anytime you have a numerator denominator, you should always check, can you cancel out anything from the numerator and denominator? If you can, that the factor you're canceling, that leave a 0, that leave a hole in your graph, in your function. So at that point, our x or y doesn't exist. So if you directly set the numerator equals to 0, sorry, if you directly set the y0 and try to solve for x, will give you a different solution than if you follow the actual method to find the x-intercept for rational. So rational, first you have to check, can it cancel anything? That's the main idea. So we start by 0, true. We have x plus 2, x squared minus 4. What can we cancel or what can we do from here? Great. See, this thing is factorable. So just get rid of the denominator will not give you the correct solution. Usually when we have one side 0, we want the denominator to disappear. So you multiply both sides with the denominator, right? in 1030, we learned that method. But for rational, we shouldn't do that. We always have to check, can we simplify the rational? That's the thing. If we can simplify, that always should be first step to solve anything. So in the numerator, we have x plus 2. And on the denominator, what do we have? X plus 2, x minus 2. And now, can you cancel anything? X plus 2, x plus 2. So what is left? On the denominator, and what is left on the numerator? 1. And now we have to try solving for x. How can you solve for x from here? What do we do? We use conjugate to rationalize. Here we are not rationalizing. We are just trying to get this x alone. Multiply both sides by x minus 2, x minus 2. So this one get vanished, no more denominator, we are happy. So what is 0 times x minus 2? 0. And what do we have on the other side? 1. Do you have any x left? So do you have any x-intercept? No x-intercept. But if you try to get in the denominator from the beginning, you multiply both sides by x squared minus 4, right? So x squared minus 4 cancel out, and you left 2 with 0 on one side, and on the other side you have x plus 2. So if you do wrong method, do you get x-intercept here? So see, you may think we are crossing the x-axis to -2, but this is wrong. Because at x equals -2, the x doesn't exist, the y doesn't exist. Why? Because we canceled it. How can it exist? That's why for rational, always simplify fast and then only look at the numerator. You can actually ignore the denominator in a rational to find the x-intercept. Just take the numerator, set it equals to 0, solve for x. The easiest method. Okay. And how about the y-intercept? Y-intercept. What do you think? Do you have a y-intercept or we don't? So how do you find y-intercept? All the x0. So if the numerator x0, denominator x0, what is left? 2 over -4, which is -half. So we don't have any x-intercept, but we do have some y-intercept. Any question? Okay, the next topic is symmetry. So symmetry means a line that divides the graph two equal pieces, and each side of that line has the same exact portion of the other side. For example, outside, our body is symmetric. If you cut through exactly in the middle, we have one hand on each side, one ear on each side, one eye on each side, one leg on each side. But inside our body symmetric? Of course not. We don't have two hearts. It fails. So mathematically, we have three types of symmetry. One type of symmetry is about the x-axis. Means whatever portion of the graph you have above the x-axis, you have the exact same thing below the x-axis. For example, x-axis symmetry. This one. If this is our x-axis, then whatever portion you have here, we have the exact same portion below x-axis. So this type of graph is symmetric about x-axis. How do we identify which equations are symmetric? You replace y with negative y, and if you have the same x value, then it's symmetric about the x-axis. Not x value, sorry. If you replace y by negative y, simplify the expression, and you get the same thing as the original one, then it's symmetric about the x-axis. Second type is symmetric about the y-axis. For example, if this is our y-axis, and if you draw a parabola, this side of the parabola is same as this side of the parabola. So this is symmetric about y-axis. But for equation, how do you find them or how do you realize them? You replace x with negative x, and if you get, after simplifying, if you get the same thing back as the original one, then it's symmetric about y-axis. For example, y equals x squared. If you replace this x with negative x, you do negative x squared. But what is negative x whole thing square? Positive x squared. So we have the original y equals x squared is same as here, y equals x squared, even after replacing x with negative x. So if you replace x with negative x, simplify, if you get the same thing as the original back, it's symmetric about y-axis. So if you have a symmetric about y-axis, it's called even function. I don't know what's the name for this one. It's not odd function. Odd function are not symmetric about x. It's symmetric about a line. So symmetric about x-axis, symmetric about y-axis. And then we have the third type of symmetry, symmetric about y equals x line. For example, this is y equals x line. So if you have a graph like this way, this part of the graph is same as this part of the graph. Let me see the different one. This part of the graph and this part of the graph are same if you consider this is your symmetry. If y equals x is your mirror, so symmetry is like mirror. If you put a mirror, whatever you see on the one side of the mirror, you see the same thing on the mirror, in the mirror. So if our y equals x line is the mirror, whatever you see on the top part of the mirror, you're going to see the exact same thing on the bottom part of the mirror. This is symmetric about y equals x line. And this type of symmetry, we call them odd function. So how do you find out which functions are odd? You replace x with negative x, but the y value changes. You change the x, but the result gives you the negative y. For example, if you have y equals x cubed, let's change this x with negative x. What is negative x whole thing cube? Negative x cube. Now, if you compare this one and this one, it's the same graph, but just the negative sign in the front. Here we have y is positive, and here we have y is negative, and function is same. So to find out which functions are odd, first you're going to see what do we get from negative y, and then we see if you replace x with negative x in the function, do you get the same thing as the negative y? So when changing x change the y, it's odd function. When changing x doesn't change the y, it's even function. And in your final exam, you're going to have definitely one of these questions. Which functions are odd? Which functions are even? So they'll give you a bunch of functions, and you have to identify which one is odd, which one is even. Now, do some example. It says use algebraic testing to check for symmetry with respect to both axis and the origin. Means are they symmetric to the x-axis or y-axis or the origin? Oh, this one is called symmetric about the origin. Origin means the y equals x line. So is it symmetric about the origin, symmetric about the x-axis, or symmetric about the y? So for in any case, we always have to change all the x with negative x and see what happens. So if you change this x with negative x, we get negative x minus y squared equals 12. Does it tell us anything? Not yet. How about we change the y with negative y? So when you change x with negative x, that's a requirement to be symmetric about origin or the thing. Y-axis. Y-axis. So in order to be symmetric about y-axis or the origin, we need to change x with negative x and see, compare that with the original function. So I change x with negative x, nothing happened. This one says change y with negative y and see what happens. If you get the same thing back, that means it's symmetric about x-axis. So this telling us it's not odd, not even. Because odd means symmetric about the origin, even means symmetric about the y-axis. So now let's see what happens if you change the y. Keep the x, but change the y with negative y. What is negative y squared? Positive y squared. Now if you compare this with the original one, what do you see? They are same. Same. So what type of symmetry we have for this equation? X-axis symmetry. Symmetric about x-axis. So it's not symmetric about y-axis. It's not symmetric about the origin, but it is symmetric about the x-axis. And this is actually true because this function has a shape this way. So you can see clearly. This part of the graph is same as this part of the graph. Okay, B. We have y equals 1 over, let's replace x with negative x and see what happens. Y equals 1 over, what is negative x squared? Positive x squared. So if you compare this with the original one, now this time they are same. So what type of symmetry we have? Y-axis. Symmetric about y-axis. So what type of function is this? Odd or even? Even. So in your homework, they will ask you a bunch of these questions. Which one is odd? Which one is even? Which one is the other one? It doesn't always work. For example, if you have odd and even mix, then which one is it? Odd function or even function? But if you see all odd, it's definitely odd. Come on. For example, x cubed minus x, it's definitely an odd function because our cube is odd number, 1 is odd number. And if you see all events are same, then it's even function. But if you have a mix, you definitely have to check. See here we have square. So square means even. So it's definitely an even function. And for this one, the other one, man. Yeah, maybe I shouldn't kick anymore. But what's wrong with this? So yeah, if you have a combination of all odd, it's odd. If you have a combination of all even function, it's even. Why are it getting this side? Okay, so y equals 2x cubed. What do you think? Odd, even, or x-axis symmetry? Odd function, because we have a cube power. Cube is odd number. And you have only one power. So when you have only one power, it's easy. You don't even have to check anything. It's just that power. So this is definitely odd function. So it's symmetric about what? Y-axis. X-axis. Not x-axis, origin. Symmetric about origin. Symmetric about origin is the odd function. And this graph actually has a shape, this one. The first one is neither odd nor even. It's symmetric about x-axis. X-axis symmetry is neither function, it's not odd or even. Y-axis. And if it's symmetric about origin, then it's odd function. What do you mean by y and x? If you want to check symmetric about x, you change y with negative y. Changing y with negative y gives it the same thing back as the original one. It's symmetric about this x-axis. So whatever you're symmetric, you're changing the other variable. The symmetric about y, it means you're changing the x from positive to negative, and you get the same thing back. It's not even possible for function if you're thinking about a function, it cannot have both symmetry. Non-function can be both symmetry. A function not. It's not plus because this negative is given in the equation, and this negative y square is positive y square. So x minus is given to us. We ignore that. Just look at the negative y square is same as positive y square. So you don't have double negative, you only one negative. That's the other question. So first we change x to negative x and we try to compare with the original one. We get stuck. There's nothing to do. This and this function, they're completely different. They have no relationship. So since they don't have a relationship, so it's neither odd nor even. So we change the y next and see is it symmetric about x. So if you want to see symmetric about y, you change the x. We tried that, but we failed. So this is failing. It's neither odd nor even. And now we change the y, but we kept our x. So x minus this y square turns into negative y to the square. So we have x minus given to us, but what is negative y square? Positive y square. So if you observe the entire thing, we have x minus y square equals to 0. This is exactly what is given to us. So since this we are saying, so it's symmetric about x, then we change the y. Whatever you're changing, it's symmetric about the other axis. If you get the same thing back. If you don't get the same thing back, it's a useless function. I mean, not useless. It's neither add nor even nor symmetric to X, those things. So you always have to change one of them. If changing one of them gives you the original back, then you are done. But if it doesn't give you the original one back, then you change the other variable and then compare with the original one. If you get the same thing back, then it's symmetric about the other variable. If you still don't get anything back, then this function is neither. It's neither symmetric about X, nor symmetric about Y, nor symmetric about origin. It's just a normal function. Now the last one, 2x cubed minus 8. If you try guessing, what would you guess? You think it's odd, okay? Now let's see. We think it's odd because we see cubic power. I said definitely C is odd because we have only one term with a cubic power. It has to be odd function. But now do the same thing, just you're subtracting a constant. Do we still have an odd function? Let's see. We change x with negative x. So we get 2 times negative x cubed minus 8. So we have 2 times, what is negative x cubed? Negative x cubed minus 8. And what is 2 times negative x cubed? Negative 2x cubed minus 8. Now, if you compare this with this one, are the same? If they are same, then it would have been even function. Since they are not same, so it's definitely not even. Now, to check add, we need to also change the y. If you change the y here, then you get negative y equals 2x cubed minus 8. So positive y should be negative 2x cubed and positive 8, right? Now, by changing the y, this is what we got. If you compare these two, if they are same, then they are odd. Are they same? No. So we compared these two, not same, means not even. We compared these two, they are not same, means they are not odd. So after changing the y, since we did not get the original one back, this is also not symmetric about x. In order to be symmetric about x, we have to get the same thing back once we change the y. So sorry, not add. This should be not x-axis symmetry. Not x-axis symmetry. And if you compare these two, not same means not odd. Let me read it again. What I mean is that. So y to negative y. If we get the same thing back, same as the original one, same as original equation, then it's symmetric about x-axis. If changing the y gives you the same thing back. Now we ignore y and we change x. If you change x to negative x and you get the same thing back, same as original equation, then it's an even function. Even function. We change x to negative x, but we get the same thing back. It's even. Now, if you change x to negative x and y to negative y, if you change both of them, and then you get the same thing back, same equation as same original equation. Since you change both of them, so it's even odd function. So this is called symmetric about y-axis, and this is called symmetric about origin. So three scenarios. Change y, get the same thing back, means x-axis symmetry. Change x, but get the same thing back, it's called y-axis symmetry, means even. But if you change both and get the original back, it means it's odd function. It means symmetric about the origin. So one side of the origin, if you have minus, for example, here, this is our origin. If you have a point here, it's minus x minus y. This point must reflect here with plus x plus y. So in order to symmetric about origin, they both have to change their sign. That's how we change both of them. Okay. Which, for the first one, first I tested the x. So I changed x with negative x, and we found it's minor. Then I changed the y. When we change y with negative y, we found this is the same as the original one. So since y gives us the same function back, it's symmetric about x.
X and you saw it was not the same, you were already. Yeah.
Odd or even, because for odd or even, we have to change x and get something back. Since we did not get something back, change the y and say it's symmetric about x. In the next one, I changed my x, and I didn't have to do many work because we found the same thing as the original one. So it's symmetric about y-axis with even function. This one I can't do anything because I already know. The one function with q definitely is odd function. But here I had to work because it's odd and then a constant. I don't know what that makes us. Odd, events, or x. So we have to test all three. I changed x. We found that it's nothing. When you compare, it's nothing. So it's not the same. That means it's not symmetric about y. So definitely not even function. And then I change my y also. And then I compare. When I change my x and change my y, are the same. Right here. I mean, I'm sorry. When I change the x and change the y, this is same as the original. Let's do it again. Changing x and y. I did it in 2 steps. So you can do it in 1 step. Insert 1 page. We have y equals 2x cubed minus 8. We changed x, we changed y individually, didn't work. Let's change them both together. Now y is negative y, negative 2, x is negative x. Change both of them at the same time and see what happens. Negative y equals negative 2, negative x cubed. I'm doing this one, D. Oh, sorry. Thank you. So I have negative y equals negative 2 x cubed minus 8. Y equals 2 x cubed plus 8. If you compare this with that, the 8 doesn't match. So it's neither. It's not symmetrical at all. The last one is an example of no type of symmetry. It's just a normal, a free equation. We don't even know if it's a function. It's a function actually, but it's not symmetric. So in reality, the graph is this one. So -8. This is the graph of this function. And you see, it's not symmetric at all. 8 units down. It's same cubic function, but it's 8 units down.
Well, you know, if it's a cubic function, so it's gonna look something like that.
Hmm?
So if you have a constant, you also gonna know it's not symmetrical.
Constant is symmetrical about y-axis. It's not x-axis symmetry, not y-axis, but it's symmetric about the origin.
So if it has a constant, then it's gonna move it up.
So it's definitely not a function. I mean, not any type of symmetric function. So in your final exam, definitely you're going to have one of these, and also in the in-class exam.
Our work for the given function. This say that
Sometimes actually it does work. Even if you have add and even, add power and even power, it falls into one of these. Sometimes it falls into neither of these. So you have to check. For example, this one, we have a cube and you have a square. What do you think? Is it add function, even function, or symmetric about x? Neither? Okay, let's check. So in order to be odd, no, in order to be even, we have to change x with negative x. So let's change that. We have y equals negative x cubed, negative x squared plus 1. So we get negative x cubed. And how about the bottom? X squared plus 1. So if you compare these two, are the same? No. So it's not odd. So not even. Not even. If they are same, it's even. It's not same, they're not even. Not even because not same. So now let's check for the odds. And here we don't have to check the axis symmetry because the question is asking for only odds. So let's change both. Negative y. Yeah. Negative y, negative x. Negative x, negative x plus 1. So negative y equals negative x cubed, and then we have x squared plus 1. So what is positive y? Negative x squared minus 1. And if you factor out the minus from the bottom, you get y equals x cubed, and then minus x squared plus 1. So comparing this with the original one, neither. Not odd. But I feel like something is off. Let me check again one more time. Insert. Wrong page. So f of x is x cubed over x squared plus 1. Now f of negative x is negative x cubed over x squared plus 1. negative f of x is negative x cubed over x squared plus 1. This is actually an odd function because when you change x and y, they are same. And in order to be odd, f of negative x has to be negative y. So now I'm confused. This is an odd function. So why did we fail? We change x and y. So negative y is negative x cubed. And then x squared plus 1. Wait. Let me see the rule again. Did I make a mistake in the rule? The graph change x by negative x and y with negative y give the same equation. Right. We didn't do anything wrong. And so negative x supposed to give you negative y. Negative x supposed to give you negative y. So what's the difference between negative x supposed to give us negative y? So how come one definition passed and one definition failed? True. But here it says if you change both of them, it's supposed to get the original back. The graph of the equation is symmetric about respect to x of the origin if replacing x by negative x and y with negative y gives the same equation back. So this is one definition. And this is our second definition. So this is definitely odd by second definition. The negative x supposed to give us negative y, so it passed. This is odd function. But how about the left side? We changed x with negative x, y with negative y. We're supposed to get the original one back. So did we get the original one back? Y with negative y, x with negative x. Oh, actually, we did get the original one back. Because if we cancel the negative from both sides, it's the original one. Come on. I made things so difficult. So change y with negative y, also x with negative x. We have negative on both sides. Cancel them. So we get the same thing back. Y equals x cubed and then x squared plus 1. It will not going to change the denominator because denominator is a square. And 1 doesn't have any x. So denominator is always unchanged. We only observe the numerator. So it is odd. So you see, why do we have a combination of odd or even? It's sometimes odd, sometimes even. It's not always odd, not always even. So you have to check which one is correct. It's the odd function, odd. This also satisfied the condition, so it's odd function. Right, denominator is always positive, unchanged. So when you even power, you can actually ignore the denominator, ignore the even power, because even power is always unchanged. Only work with the odd powers. So yeah, definitely you have to test odd or even in your exam and also in the final exam. So do the homework honestly instead of just clicking on yes, no. Actually test them and see. The more you practice, the more practice you do, the more you're going to understand this concept. Changing x and y, what do you get?
So, sorry.
Mm-hmm. Why? So for even, you just change one x. You just change one thing x. Change x. If you get the same thing as the original graph, it's symmetric about y, so it's even. If you forget about the symmetry, think about the parabola. Parabola square is definitely even, and it's symmetric about the y-axis. The symmetric about y-axis must be even. Come on. I'm not even near the podium anymore. And then symmetric about odd, it's the origin. Whatever you have on the left side of the origin, you must do the same thing on the right side of the origin. And then at that time, you have to change both x and y. So you can do it two ways. You can change x and see what you get, and then change y and see what you get. If these two are same, it's odd. Or you can change both of them at the same time and see if you get the original back. So two ways of testing. I did it here. I changed. It is connected, but I'm not touching it, so it shouldn't give us the problem. And my computer is double. Okay, so I did both methods here. I changed x and y and see what do you get. Changing x and y gives us the original. Same thing back. And then on the right side, I change x and change y separately, and then found them they both are same, so it's odd. So you can test both ways. Okay, domain and range. Did you do domain and range yesterday? I did it in my algebra class. That's why I wrote section later. So domain is the input means all the x values you can plug in your function, and range is the y values, what you can get back after plugging your x. So usually we write domain and range in interval notation. So in the interval notation, you always write the smallest number on the left, comma, the highest number on the right of your interval. And our interval has two scenarios. Either we can have parentheses or we can have brackets. And then how do you know which type of boundary you're supposed to use? If we have a solid number, or if our graph is a solid line, then our boundary should have brackets. Bracket means no problem. The number we have next to that number is a good one. We can plug in that number for our x. These are bracket means no problem. It's good. We use parentheses when you have a hole in your graph. If you have a graph, or if you don't have a graph, if you just have an equation, then you cannot have a y value. If you cannot have a y value or cannot have an x value, then we use parentheses. Or if you have something that you don't see, for example, infinity. We don't see infinity in our graph or infinity in real life. So if your interval notation has an infinity, it's parentheses. Or if you have a number that you cannot substitute for your x, we cannot have it for your y, then for those numbers, you put parentheses. And if you have a hole, if you have a graph and you can see a visible hole, an empty circle in a graph, then that empty circle is supposed to have a parentheses because the y value doesn't exist there. X and y for domain and range. Domain is x and range is the y. So y value doesn't exist. Even if your x has, but y doesn't exist. For example, if you have a graph like this, So for this x value, this y doesn't exist. So when y doesn't exist, x doesn't exist automatically. But on the other hand, if you have a graph 1 over x, when x is 0, how about your y? Doesn't exist. So see, you can substitute x with a number, but if y doesn't exist, there's a problem. So that's why I said y value must exist. And if y doesn't exist, that means you cannot use that x value because y doesn't exist. And if your graph has only one number in the domain or range, or if your function has only one number, then we use this thing. It's called curly brackets. Okay. Hopefully we have, is it full screen? Okay, hopefully we're not going to have the same problem again. So these are the rules, and now let's do some graphs example, and then we are going to do equation example. So we have a graph that looks like V-shape. Do you know what type of equation have V-shaped graph? Not square root, absolute value. So this is the absolute value graph. Now for domain, we only look at the x. Means what's the lowest x value you can find in this graph until what's the highest x value you have in this graph. This graph doesn't have any problem, right? It has all y value exists. We don't see any hole. We see a solid line, solid points. So this is a continuous graph forever. This graph is going on forever and ever and ever on the left side and on the right side. So it keeps going on forever and ever and ever. What's the lowest x value you can find in your graph? Good. And what's the highest x value you can find in your graph? Positive infinity. So for any continuous graph, our domain is all possible numbers from negative to positive infinity. And since infinity, we don't see them. We know it's there, we don't see them, just parentheses. Now for range, we'll look at the y's. What is the smallest y value you see in your graph? Definitely 3. See, this is the lowest y. So it's 3. And what's the highest y value you see in your graph? Infinity. Infinity we don't see, so parentheses. But do you see 3 in the graph? So bracket, good job. I'm actually enjoying teaching you guys. This is so smart. And cooperative and participative. Thank you so much. Any question on this graph? Okay, let's try the next one. What type of function is this? X function? No. What's the equation of this function? No. It's the horizontal line, and every horizontal line has what type of equation? y. Y equals 3. See, this is y equals 1, y equals 2. This is y equals 3. So this is not x, this is actually y graph, y equals. So every horizontal line has y equals the number. So the line is going on and on forever on the left, forever on the right. So what is our domain? Domain means x. You see, you have x value here, another x value here. X value does exist. Let me give you a point. Do you see -4, -4, 3 in your graph? You go to x equals to -4, y equals to 3. This is your graph. You have the point, x equals -4. Do you have -12, 3 in your graph? You go to x, -12, and y, 3. So your graph has x values. It's not crossing the x-axis, but it has x value. The graph is going on forever on the left side. If you have a left side graph and right side graph, it definitely have your x value. Definitely. So what's the lowest x value you can see in your graph? -infinity. And the highest x value? +infinity. So it's parentheses. Now the interesting one, range. What's the lowest y value you see in your graph? What's the highest y value you see in your graph? 3. So how many numbers you see? Only 1. So since it's only one number, we don't use parentheses or don't use bracket. It's called curly brackets. It's like curly here. It's curly brackets. Now, what type of equation the next one? It's a vertical line. So the equation of this line is x equals 8. So you do have x value. X equals 8. And domain is the x value. What is the smallest x value you see in your graph? The highest x value you see in your graph? So your domain is one number. So what are you supposed to use for the boundary? The curly bracket. And the range is the y. What is the smallest y value you see on the bottom? Great. And the highest y value on the top? Infinity. And they get parentheses. Cool, right? Not bad. These are too easy. They will not be in the exam. What will be in the exam? Something like a little bit weird, like this one. Is this graph continuous? Nope, because there's a hole in the middle. Continuous means it's going on forever and ever. There is no problem. Like this one is a continuous graph, only vertically. This one is continuous horizontally. This one is continuous forever on both sides. I mean, not continuous forever. It's continuous on the x, but not continuous on the y. But it is a continuous graph. But how about this one? It's continuous on the left side, continuous on the right side, but exactly in the middle, they have a problem. There is a breakpoint. So if your graph has a breakpoint, you have to indicate that in your domain and range. So we know on the left side is going on forever, on the right side is going on forever, right? So it's definitely for domain. We have a -infinity on the left and +infinity on the right. But in the middle, they broke. Why did they break in the middle? At x value, what? 0. So you put 0, 0, and we use the parentheses because we cannot use 0. Parentheses means the y doesn't exist. To see at 0, x equals 0, do you see any y value? We don't. We see a hole. So why is our y value? Doesn't exist. So that's why we break the entire number line into two pieces. Before 0, it's continuous. After 0, it's continuous. But exactly at 0, it's not continuous. We connect these two intervals with an U, means plus, union sign. Question? So if you don't have a continuous graph, you have to indicate every discontinuous point where the graph is discontinuous. And at discontinuous, you have to break into pieces by writing the same number twice. Once for the left interval, once for the right interval. Here we broke at 0, so we wrote 0 twice, one for the left of 0 and one for the right of 0. Now, how about range? What is the lowest y value you see in your graph? 0, not 2. You see 0. You're supposed to see 0. But do you have 0 in our graph? So what do you put for 0? Parentheses. And what's the highest y value you have in your graph? Infinity. So see, the range has only one interval, but domain has two intervals. Who did not understand what I did? I'll help you. Don't be shy. If you did not understand, please let me know so I can re-explain. Anyone? No one? Guess what? This type of question is your next final exam question. It definitely will be given some function that are continuous. You have to indicate why it's not continuous. Okay, the next one. We have two pieces. Discontinuous. So let's look at the domain. Domain is what? X or Y? X. So what's the smallest x value you see here? -2. But do you have any number for -2? Number at -2? No. So parentheses. Now -2 is for this piece. So if you continuously walk on this piece, you are walking, and you have to stop here. So what's the x value at that stopping point? 1. Parentheses, because there is no y value there. And then we jump. So we have another interval. And our next piece start here. What's the x value here? 1, parentheses. And then you walk on this piece. You keep walking, and then you stop here. 3. Good job. See, you guys are getting smarter. If you don't see y, it's parentheses. If you do see a y, it's bracket. So domain means you're walking on the x. Now let's walk on the y range. So for this -2, what's the y value we have? -4, but we don't have any y. So it's -4 with a parenthesis. Now this piece is going on forever. So we stop at 1. What's the y value at 1? 3, but do you have any y value there? Parenthesis. And then you jump from 3 to which number? 7. But do you have any 7 in your graph? Parentheses. And then you go here and you see your y value 5. Do you have, I'm going to fix that. Do you have any y value 5 there? Yes. It's almost correct, but something is wrong. Exactly. Interval should have smaller number first and then the bigger number. So we have to change their position. We cannot keep 7 to 5. We have to do 5 to 7. So we have 5 to 7. And what boundary 5 is supposed to get? Bracket and 7? parentheses. So you can work the way you want, but then at the end, you have to observe, is your position correct? Do you have a smaller number on the left and higher number on the right? If you don't, fix it. Okay? Any question? Now let me give you one more for practice. Let's say we have something like this. Something like that. And then something like this. Now let's see, this one is going on forever. Let's make it this way. Okay, let's just going on forever on the left. Let's say this is -3, this is 2, this is, let's say, 4, this is 5. And we have x value, let's say -2, and x value, let's say 5. 5. Okay, try this one. Try this, and then let me take the attendance for today. Regia? I forgot, did you say Re or Re? Regia. Okay. Hector, we have 2 Hector, right? Not Hector B, the other Hector. What's the last name? G-U-O. Marco C. Okay. Joanna. Dayanara. Gabriela M. Zainab. No. Naiva or Naiva. Hector B. No. Faria. Megan. Maggie. She shouldn't be here. Arif. Arif, are you sleeping? Is this why you are you're wearing sunglasses inside so that I can see you're sleeping? Malvina, Gabriela D, Mia, Kiara, Dago, Kristen, Prabzot, right? Rachel, Julia, Ritika, Idalia, Fabia, Angela, Isabella, Steven, Brian, Rahim, Adrian, Sihan or Shihan, Kimberly. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay. So who can give me domain? Any volunteer for domain? Go ahead. Mm-hmm. 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 Square brackets. Mm-hmm. 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 Now good. Let me ask you a question. Two, do you have any y value? Point x is -2. Do you have any y value? Not 2, right? Here the y value doesn't exist.
No.
But do you have any y value?
Yeah.
Oh yeah. Great. So do you have any problem at 2? Do you have any y value problem at 2? We do, but do you have any y value exist at -2? We do have a y value. Even though it's the same, we do have a y value. So we can combine now. We do have a y value at -2. They have the same y value, but who cares? We only care about, do we have any y value or we don't? That's the thing. So we do have a y value at -2, so we cannot split them. If y value doesn't exist, then you split. Y value do exist, you cannot split. Because y value doesn't exist. Now our next problem is at 5. When x is 5, do you have any y value? We do. Not the bottom one, but the top one. So can you split them? No. So is there any x value for which we do not have a y value? From negative infinity to positive infinity. Can you find an x value that doesn't have a y value? So what is our domain? Great. So we can see from here that we can split, but that doesn't, it's not necessary. Because we do have a y value. So combining all of these, our final answer is negative infinity to positive infinity. That's the domain.
So on the, let's say you're done with that. Not, okay, so left the first one. That.
You are going to get half points. It is not a multiple choice. But if you do the multiple choice and you see both choices, but you pick this one, because you always look for a y that doesn't exist for your x. You can find such y, then you have to split your answer. For example, the other one we did. We had problem at x here, y doesn't exist. So we have two, these are beginning point, never mind. In the middle, let me erase all these wiggly lines. In the middle, come on. So we have a problem in the middle, right? When x is 1. So when x is 1, do you see any y zero anywhere? We don't. The first y zero doesn't exist, the second y zero doesn't exist. So we cannot have our graph from left to the right continuously. There is a y, there is a x that doesn't have a y. You have to indicate that. And here we have the same problem, but there is a solution at the same time. At -2, this y doesn't exist, but this y exists. So we cannot say there is no x, there is no y in our x -2. It's wrong. It's false. Same thing here. For x equals 5, this y doesn't exist, but the other y does exist. So you do have the y value.
Technically speaking, aren't you still saying there's an y value because you put the right second? Still saying.
So to find the domain, you observe, are you missing any y value when you x? So see from here to here, there is the missing y. Here we are missing y, but that missing y is still doing this y. Your y may not be same, but as long as you have a y for your x, it's continuous. You cannot do anything with that y. So that's why we can actually combine our big 3 intervals into one interval, negative to positive. Can you do that for our range? The smallest y is going on forever on the downside, right? So you can already see our smallest y is on the bottom, negative infinity. And then this line is going on, and we do have a y here. Now, from that point, this y is going on forever. So in the middle, whatever problem you're facing, it doesn't matter. Because if you observe y's, we see all the y values in a graph. So what is the highest y we have? Infinity. So it's a weird graph. It's broken into pieces. But it has all the y values in it, all the x values in it. You see, a tricky function. It's not actually a function. Is it a function? It is a function. Because vertical line test, we have only one x, one y. Vertical line test, only one y. So it's a tricky function.
If one of those was filled in.
It's not a function. Okay, so any question on the graph? So we are going to do more finalism questions. Definitely one of these broken graph you'll see. Okay, piecewise function. These are called piecewise function because we have different pieces of the same plane. It's called piecewise function. So definitely one piecewise function. So final. And definitely you're going to, whatever in the final you're going to see in the in-class exam, definitely. And then we have a dummy question that has so many scenarios. But it doesn't matter. The main thing is we have only 2 types of problems in our function. The first type of problem is even root. For square root, fourth root, sixth root, we cannot have a negative even root. For example, square root of -1 doesn't exist. That's our first problem. We cannot have any negative inside the even root. So when you find the domain, we just have to find what makes the even root negative. Omit those numbers from the number line, and you get your domain. And then our second problem is with the denominator. Whatever function or equation given to you, what makes the denominator 0? We cannot have them in our domain. So omit them. So 2 types of problem. There's so many types of scenarios, but our main problems are only 2 things. Even root cannot be negative. Denominator cannot be 0. Now combining them, the first function is the normal even root of the numerator. For example, if we have square root of, let's say, x minus 5, which x value we cannot plug in here? Definitely 0. But is the 0 only number? 5. Is the 5 only number? Or maybe I should ask, from which number we can plug in the x values?
Has to be above 5.
5 or above 5. So anything below 5 cannot be here because they will make the function, the even root, negative. So what do? We take this function and we said whatever we have here, that thing has to be either bigger than 0, means positive, or it can be equals to 0, because we know square root of 0 is 0. So that tells us x has to be bigger than or equals 5. It can be 5, it can be bigger than 5. It definitely cannot be anything smaller than 5. Now the same even function, if I put in the denominator, for example here, 1 over square root of x minus 5. Now, what's wrong with the denominator? What number we cannot have the denominator? Definitely 0. So what makes this denominator 0? 5. So definitely cannot have 5 in our domain. And what else we have to have in our domain? What numbers we cannot have? Anything that is smaller than 5 will make the radical negative. So you cannot have anything smaller than 5. So we start with 5. Anything bigger than 5 is fine. But can you use 5? When x is 5, denominator is 0. Can you use 5? So what boundary we should put for our 5? Parentheses. If you cannot use a number or the y value doesn't exist for that number, you have to put parentheses. Oh, I forgot to put this one. This one is from 5 to infinity, and we can use 5. So we put bracket for 5. When x is 5, we have square root of 0 is 0. It's a real y value. But when x is 5 on the bottom, our denominator is 0. There is no y value. Doesn't exist. So you cannot use 5 on the denominator. Now the rationale, same problem, denominator. Let's say I have 1 over x minus 5. No radical, just normal x minus 5. Now, which number we cannot have on the denominator? 5. Can we have anything smaller than 5? Anything bigger than 5? So 5 is the only number we cannot have. So we have to break down our interval into 2 pieces. Let me do it here. We can take negative to positive infinity, everything, and plug in for our x. But there's only one number we cannot plug in, which is negative 5. Sorry, positive 5. So how many intervals do you have in your solution, in your domain? 2. This is our first piece. How do you write it? Negative infinity to 5. Can we use 5? So what boundary should 5 have? Parentheses. And what is our next interval? 5 to infinity. And boundary for 5 again? Parentheses. So see, we are telling, well, use everything from negative to positive infinity. Please do not use 5 because that will make our graph undefined or function undefined. And now combining them. What if we have even root on the top and there is a denominator extra? For example, square root of x plus 5 over x minus 5. Suppose. So now how many problems we have together? 2 problems. So you have to solve both problems. Let me do it on one page. We have numerator problem. What's the solution for our numerator problem? Anything bigger than what? 5? 5 plus 5 is 10.
Negative 5.
Negative 5. Now, when x is -5, what do you get? 0. Do you know what is square root of 0 in the numerator? 0. So y value does exist. So what is supposed to put for -5? Parentheses or bracket? Bracket. Now, look at the denominator problem. X minus 5. What we cannot have on the denominator? 5. So x cannot be 5. Can it be negative or positive? Can it be anything smaller than 5 or bigger than 5? So there is only one number you cannot have. So how many intervals we have in our domain? 2. From what to what? Mm-hmm. 5 to parentheses. Now we have to combine them, put them together. So if you add these two, put them together, what is the smallest number you're allowed to have in your function? But the top one says you cannot have smaller than -5. So see, let me graph this so you can see visually what is happening. The denominator is telling us use everything from negative to positive infinity, but do not use 5. So let me highlight this. Go from here to here and here to here. Use everything. We are free. Now numerator says, hey, you're only allowed to go up to -5 and then everything after -5. So if you put them anything here. So if you look at both of them combining, what's the smallest number you can have in your function? -5. Can we use -5? Can we have a y value for -5? So what's the boundary should be -5? Bracket. And then 5. We cannot use it. We have it, but we cannot use it. So what's the boundary? Parentheses. And then what's the highest number you can have? Infinity. This is not square bracket, it looks like square bracket, it's parentheses. So when you have multiple problems, you have to solve each one of them separately and then overlap them. That's the method. Now in the final exam, definitely one of these scenarios you're going to see. Which one? I don't know. So do your homework honestly. Do not just click or use AI to get the answer. Actually do them because you're going to see this in your final exam and also definitely in your in-class exam. Okay, so let's do some examples. Y equals square root of x. We can have 0 and anything bigger than 0. So how do you write the interval? 0 bracket, infinity parentheses. Our problem is negative, we cannot have. We use our negative problem. The next one, x plus 1. Negative what? 1. So you have to start with -1. Can you use -1? When x is -1, what's the y value? 0. So it does exist. So bracket up to infinity. So if the inside is a complicated number, for example, 2x plus 5. if you have this, it's hard to visualize what's the x value, right? So in that case, do 2x plus 5 has to be bigger than or equal 0, and then you solve for x. It should be bigger than 5 half. So when you can see it clearly, you don't have to do anything. But things that you don't see clearly, to find the solution algebraically. Okay, rational problem. What's wrong with the rational? What you don't want on the denominator? 0. So what number you cannot have this denominator? 0. Oh man. I have to restart, so give me 1 second. May it work? No. Ah, I hate that. Okay, so let me save it. Okay, you try doing this one. What did I tip? Come on. Come on. So slow. Can you work now? No. Okay, anyway. So the first denominator, we cannot have the first denominator. And what we cannot have the second denominator. So from the entire number line, which two numbers you cannot have? 0 and -5. So what should be our interval? Did you say -5 or +5 before? Mm-hmm. Mm-hmm. Perfect. So you just write down the entire interval by breaking them into -5 and 0 into two places. Oh. Oh. Okay, so real quick. X cannot be 0. X cannot be -5. Oh, what's wrong with this? Okay, never mind. I'm not going to do any more math. You guys do the math. Go ahead. You'll get the same result anyway. You have X in the denominator, you must have 0. But when X is 0, what's the solution you have? Even after combining, replace X with 0. Really? On the denominator, what do you have? What expression you have on the denominator? I combine. How did you combine? What's the least common denominator? You cannot add or subtract in your LCD. The only thing you can do is multiplication. So your LCD is X and X by X plus 5, both of them. So to refresh your memory about adding the LCD. Okay, guys, try them. I cannot write it because my computer is bugging now. So I'll do it mentally. You can still write on the paper and tell me. Copy this question. I'm going to restart my word again. Can I write? I can? Wow, interesting. But you do it anyway. Do C, D, and E. C, D, E. Practice C, D. Do C, D. Both of these. You don't have to work alone. You can talk to your neighbors. Enjoy your math. Enjoy. Ready? Who is ready for the last one? For C? Bad.
-1, and then -1 times 5 is wrong.
This is actually, this is 3.
Oh. I wrote the wrong one.
Okay.
I wrote the end.
Oh, you're doing D? Okay, no problem. Tell me the answer for D. Okay, C.
C is negative bracket.
Mm-hmm.
1,
Mm-hmm.
3,
Mm-hmm.
30,
Mm-hmm. Infinity. Okay, let's see. What's the domain for the numerator? -1 to infinity. So you cannot have anything that is smaller than -1. And when x is -1, we have square root of 0. It's good because square root of 0 exists in the numerator. Now for the denominator, what we cannot have on the denominator? 3. X cannot be 3. So how do we have to break down our interval into 2 pieces? What 2 pieces we get? Go ahead. -infinity to 3, and then 3 to infinity. So denominator is telling us do not use 3. Numerator is telling us start from -1. So when you combine these two, we have a lapping here and there. So from -1 is telling us the numerator to start with. Denominator is telling us, so we stop at 3. -1 to 3, and then we start again from 3 to 3. Done? Correct. This is our domain. How about the how about the D? Who would like to try D? Go ahead. Anyone else wants to try it? Go ahead. Bracket, -1, 5, parentheses, union, 5, infinity. So -1 for bracket for -1, right? When x is -1, what's the denominator? Can you have 0 on the denominator? We cannot have 0 on the denominator, right? So can we have bracket for -1? It has to be parentheses. Okay, now let's see. Is it correct or not? The numerator. Do you have any problem with the numerator? Is there any number that we cannot use on the numerator? Why? What is 0 bar a number, any number? 0. So is it invalid? No. So do you have any problem with the numerator? All real numbers. Numerator doesn't have any problem. It's from negative to positive infinity. When it's 5, it's 0. And we know we can divide a 0. We cannot divide by a 0, we can divide a 0. So numerator doesn't have any problem. Let's go to the denominator. Starting from which number we can have on the denominator? -1 to infinity. Can you use -1? So parentheses or bracket? Parentheses. So this is actually incorrect. What is our final domain? When you combine these two, the result is? But this one is telling us we cannot use anything less than -1. So what's the smallest thing we can use in our domain? -1. He said negative infinity, right? Yeah. So it's -1. And what's the highest number? Infinity. So see, just because you see the left, it doesn't mean the right will be the same as the left. You have to consider the problem.
I fixed up the denominator.
I can see. That's why you have a bracket.
You give me half points for that.
No, that domain is wrong. Exactly. You cannot have 0. So do not look at the formula. Look at your problem. What is your problem you have in your equation? Solve that problem. Okay, one last question. No, two last question. Last question. So we will numerator is x minus 5. Do you have any problem with the numerator? No. So ignore the numerator. Look at the denominator. What is the domain for our denominator? It cannot be 1. Why? Because 1 minus 1 is 0. We cannot have 0 on the denominator. So definitely it cannot be 1. And what else? Let's think about the overall denominator. The overall denominator, 1 minus square root of x, cannot be 0, right? Right? So we add square root of x to both sides. So square root of x, what I'm doing. Square root of x cannot be 1. We square both sides, so x cannot be 1. So this is one problem for the denominator. But within the denominator, we have another problem. What's the second problem of the denominator? Can't be negative. So x has to start from which number? Why 2? But can you have anything less than 1? The problem for this thing, only this part, is bigger than or equal to 0. The entire denominator is telling us x cannot be 1, and that tiny square root is telling us it has to be bigger than or equal to 0. Now let's see where do they meet. From 0 to everything we have for that tiny piece, and x cannot be 1 for our entire denominator. So by observing this whole thing, what do you think the domain is? Perfect. See, we have two problems. We told them here, we wrote them here. The first problem with our tiny square root, we cannot have negative. So we have to start with 0. And we can use 0 because square root of 0 is 0, 1 minus 0 is 1. Denominator is 6.
So no radical in the numerator, you don't have to worry.
Exactly. If you don't have any problem with the numerator, ignore. And the denominator has two problems. One is the denominator problem, one is the radical problem. Solve them. Okay, the last one before you go. Do you have any problem with the numerator? No, so ignore. Now the denominator. Cannot be greater than 2. Okay, so let's draw number line. So 2 here. It cannot be greater than 2 because then our radical becomes negative. But is the 2 only number it cannot have? What else makes the radical undefined? Greater than 2, right? You cannot use. Anything else? So it definitely cannot be 2 because 2 square is 4. 4 minus 4 is 0 on the denominator. Undefined. It also cannot be negative 2 because negative 2 square, 4 minus negative 2 square means 4 minus 4, 0. Undefined on the denominator. So definitely cannot be 2, cannot be negative 2. And anything bigger than 2, let's say 3. 4 minus 3 square is 9. Undefined because 4 minus 9 is negative 5. Not possible. Anything else? can you pick anything from the smaller than -2? Like -5. -5 square is what? 25. And 4 minus 25 is negative. So can you use anything from the left? No. So that is our domain. We can only use the number from -2 to +2, but can you use -2 or +2? So what should be the boundary? Parentheses. So this is how we do logically, but if you want to do algebraically, remember 4 minus x squared cannot be 0 and cannot be 0, cannot be negative. There are two conditions. Denominator cannot be 0 and the inside cannot be negative. So combining cannot be negative and cannot be 0. Combining them, our answer is 4 minus x squared has to be bigger than 0. And now we have x plus 2, x minus 2. So you see x equals -2, x equals +2. And then you see which intervals from the number line will give us something positive. So for -2, if you pick anything here, it gives us negative, we cannot have it. Anything bigger than 2, if you substitute, this becomes negative, we cannot have it.
Why did you use greater than 2? I mean, greater than 0.
Because the inside has to be positive, right? Square root of negative doesn't exist. And denominator cannot be 0. So denominator cannot be 0, and this thing cannot be negative because then it's square root of negative number.
It can't be -1. It can be -1.
Yeah, it cannot be the entire thing cannot be negative. It's 4 minus x squared cannot be negative. I'm talking about 4 minus x squared. The result cannot be negative. Now we find what makes which x values make the result positive. So every number from -2 to +2 will give this result positive, and this is what we want. Positive results for which x values. And that's our domain, the x values. Okay? So one of these scenarios definitely will see in your exam, probably multiple scenarios, and definitely one of these in your final exam.
Thank you.
And then tomorrow we are going to do difference quotients. And then, oh, we are half done with chapter 1. That means we can be able to finish chapter 1 this week. So have a good day, everyone. See you tomorrow. Don't forget to do your homework. Bye-bye.
Because I was looking at late.
What is your name? Angelo. I called you, right, Angelo? So you're fine.
And one last question, this engage. Do I have to buy it or can I just do everything on the 2-week time period?
Unfortunately, you don't have 2 weeks. You only 1 week.
Okay.
Only 1 week, yeah.
Thank you.
If you are in spring or fall, they give you 2 weeks because 15 months, 15 weeks. Okay. But now it's only 5 weeks, so they give you only 1 week.
Yeah, understandable. Okay, thank you. Have a good day.
The quizzes and exams towards the end of the
No, at the beginning.